Alright guys, so this looks a little fuzzy to me, but we're going to start. This is a 2-day section on cylinders and cones. We're primarily going to look at cylinders. The homework for tonight is only going to be cylinders. So I'd really like to start off with something simple, a simple concept that you have to get your head around. I'm trying to get my hands on a note card. So, first question I want you to think about, I'm going to bring something in here. What kind of shape is this? What would you call this? Give you a couple different looks at it. And most of you would say, oh, it's a cylinder. Of course it's a cylinder. I would argue this is not a cylinder. This is a rectangle. A very important connection for you to make is, how does a cylinder relate to a rectangle? This cylinder, three-dimensionally, is actually a note card. No magic trick here. It's a 2D note card. It's a rectangle. So a rectangle can easily be turned into a cylinder. We're going to be talking about how to find the volume of this cylinder, which is the same formula we had yesterday for prisms, or a couple days ago for prisms. It's the base area of the base, times the height. That's nothing new. How do you find the area of a base? Important first question. How do you find the area of a circle? You guys know how to find the area of a circle. You all know that's pi r squared. So that's nothing new. We go to the volume formulas on your paper. Easy thing to fill in. Same exact formula, base area times the height. If you want to be more specific and do area of a circle times the height, you can do pi r squared times h. Simple. Done. Surface area is the reason I keep throwing this rectangle up here. I want you to think of a cylinder, and I'm starting to fill in the definition for my definition for a cylinder. A cylinder is like a prism. It's almost like a type of prism. Think about what kind of base it has, with a circular base. So a simple concept. It's got a circle for a base. Another way to think of it is, it's a rolled up rectangle. It's a rectangle that's been sort of curled up and made into a three-dimensional shape. Now, why do I keep doing that? Well, I want you to think about how to find the lateral surface area. If you want to find the area of this lateral area, that is going to be a little unusual. The bases are going to be easy. That's just the area of a circle and the area of another circle. So pi r squared plus pi r squared. Done. You understand that part. How do you find the area of a rectangle? It's base times height. So that's obvious. The height of the rectangle is also the height of the cylinder. Height of the cylinder, height of the rectangle, same thing. Think about what happens to so the height is the same. Think about what happens to the base of this rectangle. What is the base of the rectangle when I roll it up? I'll put it this way. This is the base of the rectangle. What do you call, and I keep doing this for a very important reason, what do you call this distance? Distance around a circle. Oh yes, it's a circumference. So the circumference is actually right here. That distance is the circumference. So if you want to find the area of this surface here, this three-dimensional surface, it's base times height. It's the circumference times the height, which begets the question, how do you find circumference? And of course, you recall, circumference is 2 pi r. So that's what these first 3 or 4 questions are asking about. How does the base length of a lateral rectangle relate to the circular base? That's the circumference. If I look at my base and I unroll it, circumference, this distance here, is the circumference. So this lateral rectangle is what I'm talking about. Like, I think of the soup label as my rectangle. If you were to take a soup can and you recycle your soup cans at home, my mom always tells me to cut off that label, and I got to cut the label off. That label, when I cut it off, is a rectangle. When they manufacture it, it's a rectangle that they roll up. So I'm sort of drawing something called a net, which just breaks the shape apart. So this distance is the circumference. This distance is the actual height. So you get your rectangle's base is the same thing as the circumference. So this next question was, write an equation for the lateral rectangle's area. Well, the area of this is going to be base times height. And I could do b times h, but I've replaced b with c, because the base of the rectangle is actually the circumference of the base. Circumference of this base. And then I've even gone one more step and said, well, I know circumference is 2 pi r. This right here is the formula for that Campbell's soup label. 2 pi r times h. So you'll have to know the radius, and you'll have to know the height, and you have to multiply by 2 and pi. That's the capital L is my lateral surface. That's the area for that rectangle. And of course, there's nothing else really too complicated to add to it. If we've got the lateral surface, the only thing we need to add on is the base. And obviously a cylinder is going to have two bases, a top and a bottom, which I mentioned a minute ago. How do you find the area of the top and the bottom? Well, you find the area of a circle, and you double it because there's two of them. Of course, all of you know the area of a circle is pi r squared. And like I said, there's two of them, so you're going to double it. So this is a section we tend to take this and dump it into one formula. And it looks kind of intimidating, but it's just the concept that you add the bases plus the lateral area. So you're going to add 2 pi r squareds plus this circumference times height. Well, you have to memorize that. For this quiz, you'll have to know that. You'll have to just understand and comprehend that. I might put it on the top of the paper, probably not, because all it is circumference and area of a circle in one big formula. Don't get too consumed with it. You can treat this as simple as possible, I hope. This is the area of a circle doubled. This is the length of the rectangle times the height of the rectangle. So any cylinder is just really two parts. You got top and bottom. That's the top and the bottom. And you got the yellow part, which is here, the lateral. And like I said a minute ago, the volume is not a new thing. The volume is the base area times the height. It's really the same thing we've been doing the last couple of days, base area times the height. But the base specifically is a circle, so we replace b with pi r squared. So there's your two formulas. The rest of the notes is just using these two formulas, and you might be asked to find the lateral area of a cylinder, which is just this part of it. You might be asked to find the base area, which is obviously just pi r squared. You might be asked to find volume. So, got to know those two. They're the big ones. When you're ready, go for this next problem. I'll give you some dimensions for a soup can. I'm going to say it's 2 inches. I know it doesn't show up very well. 2 inches in radius and 5 inches in height. And this is one of those big family-size cans. No wimpy cans on there. Go for it. Give it a try. I'll be back in a minute in part 2.